So in our question 5, we are given the diagram. They say in the diagram, we have point P, and then point P is given as 3:4. And then what we have to do is just to make a line y-axis, which is going to be perpendicular to the x-axis. And then we have this angle starting from here today. They tell us which this is alpha. I said if it's complicated for you, this is what I propose then. Agree, you are given, if you can check here, you are given point P, you're also given point R. So there's point P, there's point R. Point P is in the first quadrant. Okay? Point R is a point in the third quadrant. Okay? But now, what did they say? They said starting from here to here, this is beta. Sometimes they usually say to learners, they can say to you, this starting from here to 808, which angle when I will say, which is going to be alpha plus 108. Agree, starting from here, this is alpha. And then if they can start by saying, okay, let's do something like this. And then we say to them, this to this, it's 180, for example. Then I will ask you, okay, what is this whole angle starting from here up until here? It means that angle is going to be alpha plus 108. So we should be careful of such questions, which we are dealing with more than one diagram. So even in this one, we're supposed to say, we are going to have something perpendicular to the x-axis. Let's have something perpendicular to the x-axis. And then we have something that looks like this. Now, if that is complicated, separate them. Make the other one to be red, make the other one to be blue. Let's start with the blue one. We're going to have the diagram with beta. Every time when they ask me something about beta, I'll concentrate on this one. So this one, we have a diagram here. And then here you have 9, and then here you have x, and then here you have y. Okay, sure. What is this angle? Starting from here to here, they told us with this one here, it's what? It's beta. It's fine. Okay? Let's go to the other triangle that we can have. The other triangle that we can have is this one. Which is in the first quadrant. Even this one, again, it's going to be perpendicular to the x-axis. So starting, this one is 90. This one is x. But now starting from here to here, they already told us, what is this? This is alpha. So every time when I look for things that I have to do with alpha, I'm going to concentrate here. Now remember, what are the coordinates? Coordinates, what they are given as x is to what? Is to y. Meaning which here, because they said this is 3:4, which this one, it's x again. This is 3. This one here is what? It's y. So you have your x is 3, your y is what? It's 4. Come to this side then. What are you given as r? You're given r, which your x is m, again. But what is this? It's your y. What is your y? Minus 12. So you put it there. Okay, you have your minus 12, and then you also have your what? Your m. Okay. Then from here onwards, you're going to look for the missing sides. Both the blue and the red have a missing side. What is missing on the red one? Let's check. What seems to be missing on the red one? What's missing? R again. Okay, what is missing on the blue one? X is missing on the blue one. Okay, if we stick to that, then we're going to start with the red one. On the red one, we're going to tell them, which, okay, we have, if we use the theorem of Pythagoras, because this is the right angle triangle, since it's a right angle triangle, we are going to tell them which we are looking for r squared, which is going to be given by 4 all squared, okay, plus 5 all squared, which says r is going to be equaling to root, okay, you square both sides. If you square both sides, you have a plus and a minus. It's the root of 25, which is going to be plus minus 5. And then r is going to be plus minus 5. That's our r. Now, what can you say about r? Which one are we going to take? Positive or negative? Positive. R can be negative. Okay? The radius is always positive. It means which our r is going to be equal to what? To 5. Therefore, it means which r is going to be equal to what? To 5. Let's get to the blue one then. What? The blue one. Oh, the blue one, we don't know what is x. We don't know what is, we also don't know what is r. So we'll leave it for now. We'll come back to it later on. First question, what does the first question say? Let's tell us which one is kind of alpha. Concentrate on the red card. Which one has alpha is the red one. Go on the red one. If you go on the red one, is the one which deals with alpha. How do you define time? So kato. So it's opposite all over adjacent. Okay, this one here is going to be defined as op all over adjacent. And then we said with these questions, we can say op represents 1, and then adjacent represents x. What is our x? What is our y here?
It's 4.
It's 4. What is our x? It's 3. 1 mark. And then we look at this one. We have 90 plus alpha. Okay? Remember, 90 can reduce, guys. And then not only does 90 reduce, 90 belongs on the vertical line. People are in the vertical line, which is 90 and 270. Not only do they reduce, they change something. Okay? If it's sine, it becomes cos. If it's cos, it becomes what? Sine. So what are we going to have here? We're going to have the cos of alpha. Okay? Now we're going to put 1 here to check whether it's positive or negative. Okay? We go to our calculator and use the +1 method. So we have sine, we have 90, we have 90 plus 1. Do you get a positive answer or a negative answer? Okay, our answer is positive. Okay? Then it means we are going to leave it as cos of alpha. How do you define cos? It's adjacent all over hypotenuse. Adjacent is 3. Okay? All over hypotenuse side, which is 5. So we'll give you 1, 2 here. Now, 5.1.3, they say it is given that, I'm not done. It's 3 marks. No, we don't. Guys, yeah. Once you use the end of a diagram, we don't want the angles. I know it's from analytical geometry, we can get the angles. Once we use an end of a diagram, we don't want to know what is the angle. I'm a question of corner. They're not asking you what is alpha. They're saying what is the tan of alpha, the trig ratio as a whole. We don't want to know what is alpha. We're not interested in alpha. Okay, let's go to 5.1.3. 5.1.3. They say if we're given which we have the 12 plus 13, the sine of beta, which is going to be 0. And then we're going to put this in a standard form, or we're just going to leave the trig ratio on its own. So we take 12 to this other side, it says which we are going to have 13, the sine of beta, which is going to be minus 12. Divide by 13, divide by what? By 13. And then it says which the sine of beta is going to be minus 12 all over what? All over 13. Now let's define sine. How do you define sine? It's up all over hypotenuse side, which is y all over what? All over r. So it means which our y is minus 12. Yeah. So let's go and put which our y is minus 12. They already told us y is minus 12. What is our r? Our r is what? It's 13. So if r is 13, we can come and tell them well, this is r is 13. What is missing? It's m. So we can determine the value of m. How do we determine the value of m? We're going to tell them which, okay, 13 all squared, okay, is going to be equal to m all squared plus 12 minus 12 all squared. Okay? Check this one to this other side. It says you have 13 all squared, which is 169. 169 minus 144. This is going to be equal to m squared. Root and root. A root has a plus and a minus. Don't forget, guys. It's like when you're going to get a positive answer, x cannot be negative here on the third quadrant. It can be positive here on the third quadrant. So x has a plus and a minus, and I'm not joking to say x has a plus and a minus. I've been saying this since the beginning. You need to write there. Like I don't understand why you don't want to write there. X is a plus and a minus. Like where does it come from? M is going to be equal to what you get as your plus minus 5. Okay. Therefore, we're in the third quadrant. Then M is going to be equal to what? Minus 5. And then this is where we get it wrong. Because now we get a positive answer. Our answer should be 2. The other one should be positive. The other one should be what? Should be negative. And then we choose based on the quadrant that we're in. If we're in the fourth quadrant, X was going to be positive. If we're in the first quadrant, X is also going to be positive. Okay, moving on to the last one then. They say determine what is going to be the cos of alpha plus beta. Yeah, you're going to use your information sheet. On your information sheet, you're going to expand this thing. If you expand this thing, what are you going to have? You copy exactly the way it is. You have cos of alpha plus the beta. This is going to be given as the cos of alpha multiplied by cos of beta minus sine alpha multiplied by sine beta. And some of these things we already know them. Like for example, we know what is cos of alpha. We just put what is cos of alpha. We don't put it on the angle here. like abanye abantu, I won't say their names. Cos of alpha. The cos of alpha, the whole of it is equaling to 3 all over 5. Cos of beta, you go to the thing that has beta. Which one has beta? Is the blue one again. How do you define cos? Cos it's adjacent, which is going to be -5 all over hypotenuse side. So you're going to have -5 all over 13. Minus, open bracket, sine of alpha. It's y all over r. What is your y?
4.
It's 4. All over r is 5. Sine of beta. It's opposite again. What is opposite? Is -12 again. All over hypotenuse side, which is what? Which is 18. So this is going to be -12 all over what? All over 18. All right, guys. If you did this, you can then invite. You can invite Mr. Kesh. I agree you can work with fractions. Right?
33 over 65.
Yeah, you are allowed to have 33 all over 65. What you're not allowed, Jessica, is to have 0. That is wrong. You use the calculator. If you stop here in the fraction, you didn't use the calculator. Kesho calculator allowed you to use a calculator without using a calculator.